Gentlemen, welcome back, and right now we're going to look at how to solve a two-dimensional acceleration problem using components. Okay, so let's assume that we have a problem that's something like this. There's a boat, and this boat has a first initial velocity, which is equal to 6.4 meters per second, and that is traveling west 35 degrees north. And 15 seconds later, so we have a time which is equal to 15 seconds. 15 seconds later, that boat has a final velocity, or v2, which is equal to 18.0 meters per second, and that is in a southerly direction. Okay, and what we want to find is what was the average velocity over that period of time. So we have our givens, we have our unknown, and we need an equation. Now, we know that we are going to have to solve this problem using the equation A is equal to V2 minus V1 all over T. Keeping in mind that these are vectors, so we're going to have to keep direction in mind. And in this case, we're going to keep direction in mind by looking at components. The key thing here is that we need to solve for this top term, which is equal to delta V, and this is going to be the target of our initial investigation. So let's start by taking a look at some of the components of these vectors. So V1 is equal to 6.4 meters per second west 35 degrees north. Let's draw that. So it's 6.4 meters per second, and it will initially be going west and then 35 degrees north. So it's going to look something like this. And we can show our angle right here, and that is 35 degrees. Which also means that we can show on here our x component and our y component. So V1y is there, V1x is right there. Let's solve for those. So if we have V1x, that will be equal to cos 35 times 6.4, which is equal to 5.24 meters per second, and that's west. And if we have V1y component, that, as you can see, that's the opposite. So the trigonometric proportion or ratio that we're going to use is sine. So sine 35 times 6.4, and that is equal to 3.67 meters per second, and that is north. Now we need to take a look at V2, and V2 is equal to, let me change that pen, is equal to 18 meters per second south, which makes our calculation of components a little bit easier. If your vector simply looks like this, if it was a straight one, V2x, obviously, is equal to 0 meters per second, and V2y is equal to 18 meters per second south. Okay. Now at this point, I'd like to make a little statement to myself whenever I'm doing the rest of the equation or the solution. Let's just make sure that we know that we're going to make north positive, and let's make let's make east positive for this, so that we know what components are going to be positive and what components are going to be negative. Okay, So we're going to make north and east positive, which means that south and west will be negative. And you could make these anything, provided you simply follow along anytime you're doing this kind of a problem. You just simply have to make sure that you are consistent throughout the problem. Okay, so let's slide this page down a little bit. And what we're going to start with here is we're going to start by targeting and finding delta V. And delta V is equal to, as we know, V2 minus V1. And we're going to find the components of delta V. So we're going to need to find delta Vx. And delta Vx is equal to V2x minus V1x. And we're also going to need to find delta Vy, which is equal to V2y minus V1y. And all of those should have vector hats as well. And let's move the page down here just so that we can do the rest of our equation and solution. And so why don't we start with delta Vx, and when we do that, we end up with a problem. We've got this subtraction here. Why don't we just add instead? V2x plus bracket negative V1x is equal to 0, because V2 has no x component, plus we want the negative of V1x. And so if we come back up here, V1x is 5.2 meters per second west. The negative of that will be east. So let's add, and if it's east, it's going to be positive, as you can see. So we're going to add 5.2 meters per second. That'll be a positive value because we're taking the negative of a negative value. So it will be 5.24 meters per second east. Okay, and the end for that is 5.24 meters per second east. Let's now take a look at our y components, and what we'll find is that we have v2y plus bracket negative v1y. And so if we go back up here to the values that we calculated, v2y is equal to 18 meters per second south, and v1y is equal to 3.67 meters per second north. So we need 18 meters per second, which is actually a negative value because it's south, negative 18 meters per second, plus bracket negative 3.67 meters per second. Why is it negative? Well, we want the negative value of v1y, and v1y was 3.67 meters per second north, but we are taking negative v1y, which means that we want 3.67 meters per second south. Okay, so in the end, negative 18 plus negative 3.67 is negative 21.67 meters per second north. Okay. Now, delta V from its components is equal to delta V x squared plus delta V y squared. And, sorry, this is Pythagorean theorem. Delta V squared is equal to delta Vx squared plus delta Vy squared. So if we do this, then the square root of 5.24 squared plus bracket negative 21.67 bracket squared will give us 22.3 meters per second. Now that's great, but we have to find a direction for this. Okay, so let's move this down a little bit and we'll extend our page and we'll solve for the direction of delta v. So just to refresh, delta Vx is equal to 5.24 meters per second, and delta Vy is equal to negative 21.67 meters per second. And by taking Pythagorean theorem and squaring these and then adding them together and taking the square root, we solve that delta V has a magnitude of 22.3 meters per second. But let's draw this, these components together. So we have a positive 5.24, which means it's easterly, and we have a negative 21.67 component, which means that it's southerly. And this is 21.67, 7, south, which means that we can now show that our delta V here is 22.3 meters per second, and we need to find theta. So in this case, we can say tan theta is equal to, as we remember, opposite over adjacent. So it's going to be 21.67 all over 5.24. And if you do that, you come up with the fact that theta is 76 degrees. Okay? So now we have the fact that delta V is equal to 22.3 meters per second, 76 degrees, and because it is east and then 76 degrees south, we'll say east 76 degrees south. Okay? But we're not done. Obviously with delta V done, that's great, but the problem requires us to find find acceleration. So we need delta V all over t. So we'll take 22.3, that's an equals, 22.3 meters per second east, 76 degrees south. And we'll divide that by the amount of time over which this occurred, and that was 15 seconds. Whoops. Try that again. That was 15 seconds. And if you calculate that out, you get 1.5 meters per second east, 76 degrees south. And there's your solution for a two-dimensional acceleration problem using components. Okay? I'll leave that with you, and please make sure that you understand exactly how to do that. This is going to become very handy when we do dynamics.